All right, you made it to the end of new material for this course. This is section 6.4. It's the last section we're going to be covering, and it's titled Working with Taylor Series. And so in section 6.3, we learned how to make or create a Maclaurin series and a Taylor series. Remember, a Maclaurin series is just a special case of the Taylor series. The Taylor series can be centered at any value, whereas the Maclaurin series is always centered at x equals 0. And we also learned that some of these series converge for all values of x, but other ones have smaller radiuses of convergence. They only converge for, say, a radius of 1 or a radius of 2. And so this last section, we're going to take those same series that we developed in the last section, in section 6.3, and you can see some of those common Maclaurin series here in the page, on the first page of your section 6.4 notes. And so we can take some common series like this, and we can use that information to come up with similar related functions. And it kind of works out much the same way we did when we were working in section 6.1 and 6.2 with using the geometric series to come up with series for other functions. So let's go ahead and take a look at some examples. Example 1 says find the Maclaurin series of each of the following functions using the series listed in table 6.1. And on exam 3, you will be provided with this table. So notice our function that we're going to be dealing with is sine 2x. The series that we're really interested in is the Maclaurin series for sine x. So we have it right here. We see that sine x is equal to negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. So let's go ahead and write that down. We know sine x is equal to this series. Okay, that was something that has been established. And it also says that this is our interval of convergence right here, which means r equals infinity. All right. So we have an infinite radius of convergence. So if we want to find sine 2x, we just use that. So sine of 2x, wherever there's an x, we're going to put a 2x. So this is going to be equal to the following series. It's going to be negative 1 to the n. That doesn't change. But in the numerator here, instead of an x, we have a 2x. We still have 2n plus 1 factorial in the denominator. And we can simplify that. So we can split apart the 2 and the x. So we could rewrite this as negative 1 to the n, and we could write this as 2 to the 2n plus 1 times x to the 2n plus 1. And it doesn't change the radius of convergence, so we still have r equals infinity. And that's it. That's how you do these problems. Let's do one more. So this one we change the input, and the next one we're going to multiply it by another function. So we already know cosine x. We know cosine x is negative 1 to the n times x to the 2n over 2n factorial. And still we have a infinite radius of convergence. So just like in the last one, we wrote down what we know. We know that the Maclaurin series for cosine x is negative 1 to the n, and then we have x to the 2n times 2n factorial. All right, that's what we know. And we know that the radius of convergence is infinity. So then, using that, just like in the last one, x squared times cosine is equal to x squared times this series that we just wrote down. So it's x squared times the sum of -1 to the n over x to the 2n, or times x to the 2n over 2n factorial. Oh, that's x squared. And so then we can just bring that x squared inside. So when we take x squared and we multiply it by x to the 2n, we get x to the 2n plus 2. So we're still going to have -1 to the n. Let's go ahead and do some math on the side. When we take x squared times x to the 2n, this is x to the 2n plus 2. It's using the product rule, right? Product rule. You multiply exponents, you add the powers. And so we end up with x to the 2n plus 2, because we're bringing this in. And then it's over 2n factorial. And we still have the same radius of convergence. Doesn't change. And that's our answer. And that is all we're covering in this section. So you need to be able to do stuff like this. This kind of stuff will be on the test. And that's it. I know that you're going to miss hearing my voice, but that is all the new content we are going to be covering. You can now focus your attention on finishing assignments and reviewing and studying. So as always, let me know if you have any questions. Thank you.